Discussion for the part test number 7 and the subject will be chemistry. Now, for the first question, 51st question, in a saturated solution of the sparingly soluble salt, strong electrolyte AgIO3, the equilibrium which set this equation if the solubility product KSP of the given salt at a given temperature is 10 to the power minus 8. So what will be the mass of the AgIO3 contained in a 100 ml of its saturated solution? Now, since it is given that it is a saturated solution, so we can say that if after this there will be no dissolution of the salt in the solution, so we can say this is the maximum amount of the solution that can solute that can be mixed up in the solvent. So now we'll go with the equation. What is the equation given to us is, so the first of all the equation given to is AgIO3 in a solid form giving us Ag plus and IO3 negative anion in the aqueous form. Now, what is given to you is this AgIO3 salt in its solid form is getting dissolved in the solvent, which is Ag plus IO3 negative cations and anions are forming. Now, the solubility product of this can be taken by the concentration of product ions divided by the concentration of the reactant ions. Now, we will not take the concentration of the AgIO3 as it is given in the solid form. In the solid form, we generally take the concentration as the unity value. So, for example, for instance, we say concentration of Ag plus is, let's say, S, and similarly the concentration of the Ag plus will be, IO3 negative will be S only. So now the concentration of the products will be S into S divided by unity. Now KSP is given to you as 10 to the power minus 8. So what we will do is 10 to the power minus 8 is equals to S squared. So the value of S, which is the concentration, we got as 10 to the power minus 4, and it will be in the moles per liter. So we can say in the 1 liter of the solvent, or we can say in the 1 liter of the solution, there is 10 to the power minus 4 moles of the AgIO3 solution, or we can say Ag plus and IO3 negative. So now what is asked for us is 100 ml of the saturated solution. So we can say in 1 liter of the solution, there is 10 to the power minus 4 moles of AgIO3. And we can say after that, these many number of moles in the 1 liter of the solution, we can find out in the 0.1 liter, or we can say in the 100 ml of the solution. So again in 100 ml, so we can say 0.1 liter, there will be 10 to the power minus 4 moles multiplied by 0.1 liter, and it will be per liter. So the answer here will be 10 to the power minus 5 moles. Now we are asked the mass of the compound, not the moles of the compound. So what we will do? We will multiply the number of moles that we are getting to the molar mass of the compound. So the molar mass of the compound given to you is the 283 grams per mole. So what we will do is mass of salt in 100 ml will be number of moles multiplied by 283 grams per mole. So what we will get? We will 10 to the power minus 4 moles multiplied by 283 gram per mole. So what we will get? We will get is 2.83 into 10 to the power minus 2 grams of the salt will be present. So the answer will be the B option, which is 2.83 into 10 to the power minus 3 grams. Now the next question, for a reaction A to B, if this equation, the frequency factor and the energy of the activation for the reactions are. So now for the reaction A to B, this question is from the Arrhenius equation. Now we know that for the Arrhenius equation, we know K is equals to A into e to the power minus activation energy upon RT, or we can say what? In terms of log K is equals to log A plus, minus EA upon 2.303 RT. So now in the given equation, log K is log K, which is in the second inverse. 14 is the log A value. So by comparing the two equations, what we got? We got log A is equals to 14, or we can say A is equals to 10 to the power 14, and it will be second inverse. Log A will be 10 to the power minus 4 second inverse. Now why second inverse? Because this K is equal to second inverse, so this term individually and this term individually must be second inverse only. Now after the value of A, we have to find out the value of EA. So how will we find out the value of EA? We will compare this thing with this one. So what we will do now? Minus EA upon RT 2.303 must be equals to minus 1.25 into 10 to the power 4 upon T temperature. So what we will get following this, we will get as 239.34. So what we will get, the value of this minus will be cancelled out, and after so temperature will be cancelled out. So we will get EA value as 239.34 kilojoules. So the option number A will be the correct option. Now again from kinetics, the rate constant of a reaction at a temperature 200 Kelvin is 10 times less than the rate constant at 400 Kelvin. For instance, let's say T1 is your what? 200 Kelvin, and T2 is what, your 400 Kelvin. So what we will do? Let's supposedly K1 is the rate constant at 200 Kelvin and K2 is the rate constant at 400 Kelvin. So what we will get is, it is given the rate constant of a reaction at 200 Kelvin is 10 times less. So what can we say? The K2 by K1 ratio is given as 10. So this is the takeaway thing from the first line. What is the activation energy of the reaction? Now how can we find out the activation energy of the reaction? In the previous example, what we did? We used the Arrhenius equation. Again we will here use the Arrhenius equation, but this time the integrated form of the Arrhenius equation. Now the integrated form of the Arrhenius equation is log K2 by K1 is equals to minus EA by RT, or I can say plus EA by RT, and it will be 1 upon T1 minus 1 upon T2, and here we will have 2.303. Now log K2 by K1 is what? Log 10. EA we have to find out 2.303 So this temperature will not be here, it is 1 upon T1 minus 1 upon T2. So what it will be? 2.303 R. Now 1 upon T1, 1 upon 200 minus 1 upon 400. So after solving this thing, we will get EA value as 921.189 R. So this will be the exact value for the for the EA value, which is 921.189 R, which has been given in the option B. So the correct option for this question will be the option B. After this, again kinetics question. Now this question is from the first order reaction. So it is given as a for a first order reaction, a plot of log A minus x against time is a straight line with a negative slope equal to. Now first of all, what is given to us? First order reaction. In the questions of thermodynamics, equilibrium, kinetics or electrochemistry, always make sure that you are reading the question very finely and very nicely, precisely, and then we do have to understand the meaning of each and every word given to you. So first of all, from the first order equation, what we can write? For the first order equation, what you can write is log A, or in the terms of ln we can write as ln A at time t is equals to minus kt plus ln A at time 0. What is A here? A is the concentration of the reactants present at time 0, and AT is the concentration of the reactants present at the time AT, like t time. So what it will be? It will be in terms of log. I can write again log AT is equals to minus kt upon 2.303 plus log A, which is your given equation. Now, a plot of log A minus x. What is A minus x? As we know, A is the initial concentration, x is the concentration used. So, what it will be? It will be your AT value, like left concentration of the reactant. So, log AT against time is straight line. So, against time. So, this is the time. So, this is your x axis and this is your y axis. So, apparently, this has to be your slope and this has to be your c value. Now, for the slope, negative slope equal to, now they have already mentioned the negative slope. So, answer C cannot be here because the slope has to be negative. So, now the slope value from here we will get is k upon 2.303 with a minus sign. So, in this question, we just had to compare the general equation to the given equation so that we can get the answer. So the answer for this question will be the A option, which is minus k upon 2.303. Now again, this question is from the collision and we can say temperature coefficient. So now we know that what is temperature coefficient first of all. Temperature coefficient is like del T, we can say, which is change in the temperature during the course of the reaction. So we'll say the change in the ratio, or we can say the change in the rate constant raised to the power change in the temperature is our temperature coefficient, TC, temperature coefficient. So what is given to you now? Temperature coefficient of most of the reactions lies between 2 and 3. It is a correct statement. Why it is a correct statement? Because when you are changing the temperature by 10 degrees Celsius, it is generally the twice or the thrice rate will be increased. For example, what I am trying to tell you here is that K1, for example, at some T temperature is there. So K2 at the T plus 10 degree will be K2 is equals to 2 times K1. Generally, I will say nearly equal to twice or the thrice of the initial K value which was on the T1 temperature. So it is correct, it is between 2 and 3. Now the reason for it is because of increasing the temperature. What will we be increasing? We will increasing the effective number of collisions. Mention this thing, I am not saying the total number of collisions, I am saying effective number of collisions. Now from the collision, how do you know that for the effective number of collisions? Why I am mentioning? Because let's say this is any equation I can say. Now for the effective number of collisions, what they have to collide that much that the energy produced is greater than their EA value or at least equal to their EA value. So that this energy barrier has to be crossed for this reaction to occur. Now if the energy barrier is not achieved or is not passed by, so the equation will not be happening there. So hence the effective number of collisions are to be required. So it doesn't matter upon only the number of collisions. It is depending upon the effective number of collisions. This is true that on increasing the temperature, the total number of collisions will also be increased. But the real thing is the total number of collisions we have to check for the effective number of collisions. So if effective number of collisions are increasing, then only we will say that that was the primary reason for the temperature coefficient and for the increase in the rate constant of the reaction. So the answer will be the B. Statement 1 and statement 2 both are the true, but the statement second is not the correct explanation for the statement 1. Okay. So this is a very well-known reaction when when any alkyl halide, that is any alkyl halide reacts with some aryl halide. That what I am saying is alkyl halide reacting with some aryl halide in the presence of Na, or we can say 2Na. So then this reaction complete is known as your Woods-Wittig reaction. And what will be the products here? The products here will get, for example, some ARX and RX dash is there. So what we will get? We will get AR, R plus में we will get this 2H2O and we will get the NaX. So we will get NaX, or I can say NaX dash. I will get. So this is your Woods-Wittig reaction. Now, chlorobenzene reacts with Mg in dry ether to give you some compound, and with ethanol, what does this compound is mean? So now, first with chlorobenzene, so C6H5Cl reacts with Mg in presence of some dry ether to give a compound A, which further reacts with ethanol to yield what? So the first is this. So as we know, this is very well-known reaction, so we will get what? I write this one as Mg and then C. So now the driving force for this reaction must be, for example, this is your Cl. So the charge on this carbon compound, which is sp2 hybridized is positive, and the Cl is obviously Dl negative. So now as you know, the sp2 carbon hybridized carbon center is enough electronegative, but still it is having the delta positive charge which is not that stable on it. So it will try to get this delta positive charge removed, or it is converted to the delta negative. So what it does, it rather than fall for the attachment of the Mg, magnesium, rather than the Cl center, because in this way the metal will be the delta positive and it will be the delta negative. So for this was the driving force for this reaction. Now after the reaction with what? C2H5OH, ethanol. Now we know that this is very good base. It is a very strong base here, and it can abstract any acidic proton. Now acidic proton is there, where it is connected to the oxygen. So it is your acidic proton. So it will be removed, and what will you get? You will get as this positive charge will go here. So you will get hydrogen plus C2H5O negative Mg, Ca will be there. So you will get a major product as your benzene. So the major product in this equation of the reaction is the benzene. So now CX bond is strongest in. It is being asked to you that the CX bond is stronger in which of the following compound given to you. So the strongest bond is present in where? So there is CH3Cl. Now H3 is common in all, so I write CCl, CF, CBr and Ci. Now we will judge, or we will determine the strength of this bond purely on the basis of what is the electronegativity of the side element. Why so? Because the more the electronegativity of the side element, more will be the electropositivity of the carbon. So we can say more is the electronegativity of this element, is more will be the delta positive of the carbon. Hence there will be polarity difference and the bond will be highly polar. So more the polar the bond is, more it will be stable bond in comparison to others. So we can say the CH3F will be having the most strongest CX bond in the given option. Now, in this question, what will be happening? 3C2H5OH plus PCl3 and the C2H5Cl plus X is getting formed. So, in this reaction, what is happening? This ethanol is reacting with PCl3. Now we know that PCl3 is what? PCl3 is your better chloride donor. So, what it will do? It will do Cl will be going to the C2H5 positive. This reaction will be SN reaction. So substitution reaction will be, and it will be nucleophilic substitution reaction. Nucleophilic substitution reaction, and the other nucleophile is OH negative will be leaving and Cl negative will be entering. So what will happen? C2H5Cl is there, and now what is X? Now you can see that phosphorus is there in the compound and oxygen is there in this compound. So as we know that the phosphorus oxygen bond is one of the strongest bond in the chemistry. So their affinity for getting formed the P of phosphorus oxygen bond is very high. So what will be happening here? It will be H3PO3 will be the final product in the, as we can say, X will be H3PO3. So this reaction gives you 3C2H5Cl plus H3PO3. So the answer will be the C option given to you. Now after this, the next question is, okay, so identify the X in the following reaction. So in the following reaction, what is the reaction given to you? So what is the reaction given to you is, this reaction is popularly known as the carbyl-amine reaction, because it is a carbyl group and it is an amine group. So this is the carbyl-amine reaction. Now what is given to you? That I identify the X in the following reaction. Now we have to check what this X will be. We have to check that what this X will be. Now we know that what is given. For example, as we know, the X here will be CHCl3, and how so? Because if we take a CHCl3 and there is a strong base present, which is KOH. So what will be happening? The KOH will be taking this highly acidic hydrogen. Why so? Because there is a negative minus I effect of this 3 chlorine on it. So it will be very much acidic. So hence it will be taken up by the KOH. So what will happen? CCl3 negative will be there, and you know from there this is the generation of carbene. So what will happen? We will get CCl2 negative. CCl2 is a carbene and it will be the intermediate. Now after this what will be happening? The KOH is there, so now CH3 and C is there. Now this carbon, where it will attack? It will go to CH3 and H2. Now as we know, N is having a lone pair and carbene is an electron deficient species. So what will happen? It is an electron deficient species. So nitrogen is having the lone pair. So what will happen here? Now nitrogen cannot make the 4 bonds. So one hydrogen will be leaving and one chlorine will be leaving. Again, the nitrogen will give the another electron to the carbon, so it will be C double bond N. So again, the one Cl has to leave and one hydrogen has to leave. Ultimately, what we will get? We will get the isocyanate compound here. So the CH3 and C will be the final compound, and the X in this reaction will be the chloroform, which is your B option. After this, another question. Now, Grignard reagent is prepared by the reaction between. So, as we know, this is a very famous reaction, magnesium and alkyl halide. So, the magnesium is the metal that we use, and the alkyl halides. For example, Mg plus Rx. In the presence of dry ether gives you what? Mg. Now, 2-bromopentane is heated with potassium ethoxide in ethanol. The major product obtained is, so let's go first 2-bromopentane. So 2-bromopentane, 1, 2, 3, 4, 5, and it will be bromine here. So I am writing this way, H. So what I am writing is, I am writing this hydrogen as B hydrogen, I am writing this hydrogen as C hydrogen. So this is a B hydrogen, this is C hydrogen. Now what is given to you? It is with potassium ethoxide. Now just by looking at the reagent, you can say that which reaction it is. This is a very strong base. It is a strong base. There is a presence of two beta hydrogens, and there is a strong base. So which reaction will be happening? Elimination reaction. Now elimination reaction, the A2 reaction will be happening because this is a 2-degree carbon center. So it will be the A2 elimination will be favored here. Now the selectivity comes. HC will leave or HB will leave. So which hydrogen has to leave to give the alkene? Now it will be decided upon what? It will be decided upon the base given to you. As we know, the base is not that much bulky base. So we will have what? We will have the stage product as the major product, depending upon what? The base or the conditions provided to you. So now for the Safezer product, which hydrogen will be leaving? So HB has to leave. So what will be the mechanism here? First HB will be taken up by this base and this negative charge will be here. So the negative charge will be what? It will be coming here and the Br negative has to leave. So this is a very fast and quick reaction. It is a single step reaction here. So what will happen? CH3 is here and C double bond. Yeah, so this will be CH3 is there and then CH2 is there and then C double bond C and it will be CH2 here and single hydrogen is also there. So you will be getting this product as the major product. So there must be some minor product also. Now this will be a trans alkene rather than a cis alkene. So what will be there? It will be a trans alkene. So it will be a trans alkene rather than a cis alkene to us. Hydrogen will be here, the hydrogen will be here. Now why the trans alkene? Because during the formation of the intermediate, the trans alkene is more stable as the bulkier groups are at the poles apart position. So it will be more stability in the product. So the trans will be major, and if you get what? If you get this HC out, so it will be your HC will be giving you Hoffman product which will not be stable. So which answer will be there? It will be trans pentene and 2. It means trans pent 2-ene. So in the next reaction, C6H5Cl prepared by aniline with. Now the reaction we have to start is from the aniline. So aniline is given to you as NH2. Now as we know, this is a very popular reaction which is diazonium reaction, in which we are making some benzene diazonium salt, and in this what is happening? The reagent that we require is the HNO2, which is a nitrous acid. Either the HNO2 will be giving or they will give you what? They will give you some what? NaNO2 plus HCl. They can give you this also. Now the product that will be forming here will be N2 positive and Cl negative will be counter anion. So this is a diazonium. It will be a diazonium salt and it will be giving you N2 plus Cl negative. So after this, then heated with Cl2. So what will be happening after heating Cl2? You will get what? The Cl negative from here will replace this thing and you will get directly Cl and you will get directly N2. With some what? You will get N2 nitrogen gas will be released in this process. So this is your diazonium reaction. This reaction is also known as your Sandmeier's reaction. So the name for this reaction is the Sandmeier's. It will be a Sandmeier's reaction. So now in the other question, okay. So now the equilibrium constants Kp1 and Kp2 for the following reactions are given to you respectively in the ratio of 2:3. So for example, if I am saying Kp1 for this reaction, so what is given to you is Kp1 upon Kp2 are in the ratio of 2:3. If the degree of dissociation of A and B are equal, So what will be the total pressure at the equilibrium? So we are supposed to find the total pressure. If we can get the partial pressure of each compound if separated, so we will get the answer here. And if we get the partial pressure, then we can get the answer here. So the first equation given to you is A is given to as the 2B and E is given to as the Q plus R. So at time t is equals to 0, what we can say that the number of moles of this A was 1 and it is 0. Or I can say at time equals to equilibrium will be 1 minus alpha, alpha taking as what? Degree of dissociation for the A. So it will be 2 alpha here. In the same way, 1, let's say 1 more, it will be 0 and 0 for them. And again, if alpha is going from here, it will be some alpha and alpha here. So now we have to find out what? We have to find out the Kp1 and Kp2 for the both the reactions. So what will happen in the Kp1? So we can write the Kp1 will be 2 alpha square upon 1 minus alpha. And Kp2 will be what? It will be alpha square upon 1 minus alpha here. So what will happen now? It is given as Kp1 and Kp2. Now we can do what? We can do we can say the total partial pressure of total partial pressure of B upon total partial pressure of A. So we can also write this thing as well. It is the K rate constant for the equilibrium time. So now what will happen in the next phase? Or I can write how? So the Kp for this reaction first. So it will be P for B square upon P for A. Or I can write as Kp2 is equals to Q R divided by M for the P. So this is the pressure I am writing or the concentration. So this is the pressure present at the equilibrium conditions for all these reactions given to us. Now what will happen? So now the partial pressure is equals to, as we know from other thing, the partial pressure for this thing is known as partial pressure for A. It will be equals to mole fraction of A and total pressure. Again the partial pressure for B we can say mole fraction of B and total pressure of the reaction present. So what will be happening now? So I can say that this Kp1 will be is equals to, now more these are the number of moles. So for Pb it will be what? 2 alpha upon 1 plus alpha square, and it will be total pressure square. In the next time we will get what? 1 minus alpha upon 1 plus alpha is the mole fraction of A, and it will be a P total. Again for the Kp2 what will I write? For the Kp2 I will write what? Kp2 will be what? Kp2 is this, it is given as the partial pressure of Q and partial pressure of R. So it will be alpha upon 1 plus alpha, and again for the same for the R, so it will write I'll write square, and it will be again P total square, and the downside it will be 1 minus alpha upon 1 plus alpha, and it will be your P total. So this is the new equations we got for the Kp1 and the Kp2. Now for the Kp1 and the Kp2, what I am using it now. What I will get is, so now for Kp1 by Kp2, what will I do? I will say, because it is the ratio given to me, so Kp1 by Kp2 the ratio was equals to what? 2 by 3, and it is equal to Pt square, so Pt square to Pt square. So what will it will be getting cancelled out, and 2 alpha square 1 alpha square is getting cancelled again. So what it will be? It will be 4 alpha square for Kp1, this is a 4 alpha square, and downside it will be 1 minus alpha. And this thing to be reciprocating there, so what will happen? 1 plus alpha, 1 minus alpha. So upside it will be 1 minus alpha and it will be a alpha square. So what will happen? So it is not alpha square. What will happen? It is a 1 plus alpha square. So it will be 1 plus alpha there. So now it is 1 minus alpha and it is 2 alpha upon 1 minus alpha. So now what will I get? It is 1 plus alpha and 1 minus alpha. So it will be alpha 1. So what we will get from here? So we will get as alpha kp1 upon kp2 is equals to 2 by 3 and we will get as what? So for p1 and for p2. So this p total is 1 and p total is 1, p total is 2, for p total is 2. So what we will get is, we will get as 4 alpha square upon 1 minus alpha and we will be doing it as pt1 upon pt2. So what we will get as 4 alpha square upon 1 minus alpha square. So now this is equal to what? It is equal to 2 by 3. So we will get as kp1 by kp2 is equals to kp1 by kp2 is equals to 4p1 by p2 and which is equal to 2 by 3. So p1 by p2 is equals to, what we will do? We will, it will be this side and it will be 1:6 here. So this will be the thing that we will get. So here what we will get? I am revising it. Here what we will get? kp1 upon kp2 will be, kp1 upon kp2 will be equals to 4 alpha square, 4 alpha square upon 1 minus alpha square. You will be getting as pt1 upon pt2 here. pt1 upon pt2 here. So we will get pt1 upon pt2 here and hence we can solve this thing. We will get this is the answer. So 1:6 will be the answer. It was a very good question. So again it is a very good question, 65th question. So what is given to you is that 100 ml of a buffer solution contains. So if, for example, so volume of the buffer solution is given to you as 100 ml. Contains 0.1 molar each of weak acid HA and salt Na. So what is given to you? The concentration of Na is given to you as 0.1 molar and the concentration of HA is given to you as 0.1 molar. Now how many grams of NaOH should be added so that the pH will be 6 here? So what we will do? We will say that pK here will be equals to minus log K, and why so? Because K and HA here. So now if I have to find out the K is given to you. So the K for this will be equals to 10 to the power minus 5. So how many grams of NaOH should be added to the buffer so that its pH will be 6? So first we will use what? We will use the Henderson equation that says what? The pH will be is equals to pKa plus log of concentration of A anion and the concentration of your acid given to you. So for the acidic buffer we will use this Henderson equation. Now as we know that pK is equals to minus log K, so we can get the value of K as well, and pK we can get from the minus log K which is given as a 10 to the power minus 5. So what we will say? We will say that now this is done. pK we have find out. Now for the pH, how can we find out the value of the pH from the given equation? Now as we can say that if the x moles of the x moles, so now I can say, let's say the x moles X moles of the, what we say, X moles of NaOH are added to the acid. Now acid is also single proton donor and NaOH is also single OH donor. So the X moles are of the NaOH are given. So what will be there? It will be H2O plus concentration of Na. So now what will happen? After this, how much Na final, what will be the final moles of Ha here? So if X is there and it was given as what? 0.1 molar. So the final moles of Ha concentration we have to say. So it will be what? It will be 0.1 minus. Sorry, what I will do is, yeah, it was totally 0.1. So out of this, the X molar, or we can say the X moles were there. So what will happen? The X mole is there. So now what is the total number of moles of the there? Moles were there. So it is 0.1 in 100 ml of buffer solution. So what will happen? This is equal 0.1 is for 1 liter. So what we will do for the 100 ml, it will be 0.01. So what we will say, it will be 0.01 moles of the HA were initially, and now the left HA moles are the 0.01 minus X. Because the NaOH is a single OH donor, so what will happen? It will only utilize the single moles of the what we say, at molecule of the HA. Now what will happen? Similarly, we can find out the number of moles of A negative. How can we find out the number of moles of A negative? It is there. So now initially what was happening? There was a dissociation of weak acid also, 0.1 molar each of weak acid. So what will happen? Now there is dissociation. So the final moles of A negative kitna hoga? Before dissociation it was present, and after the dissociation of the NaOH plus HA, what will be the presence of Na negative? So what it will be? It will be, initial moles were how many? It will be again 0.01 moles, but this time it will be plus X. Because whatever is the moles of NaOH you are taking the same moles what the Na negative will be forming. So now what will happen? Now for putting all this, now we have the value for the pH as well. Now we have the value for pK, and we have the value for A negative and HA. Okay. So we have to find out the pH. pH is given as the 6 value. So now pK is there. So log A negative upon log of HA is there. So what we have to find out? We have to find out the value of this X. This is the number of moles of the NaOH value. So pH is equal to 6. pK is here. What we say? We can find out from here. It will be what? It will be minus log K. So it will be plus 5. And this is the given to you. So now after solving this equation I am writing again here. So it will be 6 is equals to 5 plus log 0.01. So it will be 0.01 plus X, and it will be 0.01 minus X. So now this equation we have to solve ultimately. Now after solving this equation, what we will get? We will get the X is equals to So this is the final equation that we got now. After solving this, we get the X value is equals to 0.00818. So 0.00818 moles of the NaOH. Now they are the number of moles, and we are asked for the how many grams. So what we will do for the mass of NaOH, what we will do? The number of moles are multiplied by the, what is with there? The molecular mass of Na. How much it will be? It will be around 40. It will be 40 grams per molecule. So after solving this, we will get 0.328 grams of NaOH will get. So nothing was there. The only thing in this question we have to do is that the NaOH is dissociate. NaOH, whatever NaOH is, what we say, neutralizing the Ha. So that A negative will be forming, and there is some A negative initially also. Again for the Ha, what will be the left amount of Ha? So the left amount of the Ha will be the initial number of moles of Ha minus subtracted the number of moles of Ha that gets neutralized by the NaOH. Now the number of moles of Ha neutralized by NaOH will be equals to what? They will be equals to the number of moles of NaOH. Why so? Because they both are the what we say compounds, in which both are the, one is monoacidic and one is monobasic compound. So there will be no difference between them. Now we have to check for the next question. So it was the 65th question. Now for the 66th question, what we will do? Now again 3x plus y, x3y. This amount of x3y is affected by. So now the amount at equilibrium. As we know that amount at equilibrium can either be done by the pressure or it can be temperature also. Now we will say what? The temperature and pressure will be affecting it. But the real thing was catalyst. The catalyst can only change the rate of the reaction, means how fast or how slow the reaction can go. So how fast or how slow the reaction is. Always remember, the catalyst never hinders or hampers anything or affect anything in the equilibrium condition. The catalyst can make the reaction faster, the poison can make the reaction very slower, but they will not change the equilibrium condition. Yes, they can change the time taken by the compound for the equilibrium to reach the equilibrium, but it will not change the equilibrium condition. So the option will be the A option, in which temperature and pressure will be the only thing which will be affecting the equilibrium condition. Now, auto-ionization of NH3 is this, and with the K value is this, and the number of amide ions present in the per millimeter cube of the pure liquid NH3 is. Now, what you are provided. For example, in this equation, I am taking this one. 2NH3 is giving you . So what will happen in NH4 plus NH2 negative? The K value, so for example, if I am taking this one is X moles, and it will also be X mole, and if it was, let's say, 1 mole, it will be 1 minus X left here. So formation of the NH4 plus NH2 negative will be same, and the X mole for the both will be forming. So what will happen now? The KNH3 value is given to you as, so KNH3 will be equal to what? X square, X into X. So it will be X square will be equals to 10 to the power minus 30. So X square will I get as 10 to the power minus 30, or X I can say what? 15. So this is the value for the number of moles of NH2 negative, or the numbers of moles of the, what I can say, number of moles of the NH4 positive. So what will happen now? These are the number of moles, or what we have to do? We have to tell the number of amide anions. So these are the number of moles. So it means this is the number of moles present in the 1 liter of the solution. So you can say 1 liter of the solution gives you 10 to the power minus 15 moles. Or we can say 10 to the power minus 15 into moles into Na number of the anion, which is mole inverse. So what we will get? We will get 10 to the power minus 15, and we will get a 6.022 into 10 to the power 23. Now it is asked per millimeter cube. So 1 liter is how many millimeter cube? It is 10 to the power 6 millimeter cube. So we will multiply by the 10 to the power 6. After solving this equation, we will get the 602 as the total number of the amide anions present in the reaction. Okay, then moving to the next question. Now At 540 Kelvin, 0.1 mole of PCl5 are heated, some volume is given. So the presence of equilibrium mixture is found to be 1 atm. Calculate the Kc and Kp for the reaction. So first we have to find out the Kc value and then we have to find out the Kp value. So what we will do for the Kc, what we require? Kc के लिए हमें चाहिएगा क्या? Kp concentration of the products upon concentration of the reactants we will require. So now what is given to you? Temperature is given to you as 540 Kelvin. Number of moles of PCl5 are 0.1 mole and total volume is given as 8 liter. I guess pressure is also given. So the presence of equilibrium mixture is pressure paper. Pressure equilibrium will be equals to 180. So now what will happen? The concentration of products of the concentration of reactant. Now writing the equation as PCl5 is giving you PCl3 plus Cl2. So what will happen? Supposedly, if you are provided with how many number of moles? 0.1 mole of PCl5. So at the time 0, it will be 0.10. After some time, it will be 0.1. And what we can say? For example, if what 0.1 mole was there, so from the 0.1 mole of PCl5, how many moles of the PCl3 and Cl2 will be forming? For example, now 0.1, let's say minus x, and it will be your x and x. So what will happen? Now volume, total volume is given, temperature is given, so total pressure is also given. So can we calculate the total number of moles present at the equilibrium? Yes, we can. So what will be the total number of moles here? It will be 0.1 plus x total number of moles. So these are the number of total moles. So now we are provided, we will use the equation as PV is equals to nRT. Now P is there, PV by RT is equals to what? Total number of moles, it is 0.1 plus x. So after solving this equation, you have to find out the x value, that is the total number of moles PCl3 and Cl2 are getting formed, which will be equals to, or we can say the concentration can also be there, or we can say the total number of moles will be 0.080. The total number of moles 0.80 moles will be forming for both. Now, after this total, what we will do is we have the number of moles of each compound which is reactants as a product at the equilibrium time. So can we calculate the concentration for them? Because volume is given as how many? 8 liters of the volume is given to us. So for example, if I am doing what? Kc, if I am writing so now I can write Kp as the concentration of what? Cl2, concentration of PCl3 and concentration of PCl5. So what will happen? Now what is the number of moles of the PCl3 and Cl2 is forming? 0.08. So it will be 0.08 into 0.08. And what we will do? We will say these are the number of moles, but what we need? We require the concentration here. So what we will do? We will say that it will be 0.08 multiplied by 0.08 and divided by the concentration as well. So what will happen? For the concentration term, we will take what? 8 liters and 8 liters. Now again for the PCl5, what we will do? Now we have to take the number of moles left. So for 0.08, we have to subtract them from 0.1. So it will be 0.1 subtraction 0.08 and it will be again 8 liter. So this is the one concentration. This is the upper concentration in the numerator. So what we will get Kc after solving all this is 0.04 mole per liter. So Kc will be is equals to mole per liter. Now, in the Kp and Kc, you know the formula is Kp is equals to Kc into RT, and it will be a del Ng. Now you know that the del Ng value is what? PCl5 is giving to PCl3 plus Cl2. So 2 minus 1, the products minus statement, it will be 1. So del Ng value is 1. Kc we can put from here. So what we will put? We will put 0.04, and we will put R, and the temperature value is what? 540 Kelvin. 540 Kelvin, and it will be del Ng is directly is 1 only. So what will be the answer for the Kp? So the Kp will be 1.77 atm for this question. So Kc is 0.04 mole per liter, and this one is in the A option directly. So this was the question number 68. Now after this, what we will do is we will do the remaining questions obviously. So now coming to the another questions. So which of the following solution will have the highest pH value? Now this is a strong base, that is a strong acid, and there are some. This is a salt of a strong base and the weak acid, and it is of the strong base and the weak acid again. So now we know that how to find out the pH in these terms. So pH for the weak acid and strong base, how can we find out? We can find out as the pH. I am just giving you the formula for the calculating the pH. So the pH will be equals to 7 plus half pKa, 7 plus half pKa plus half log C concentration. This one is for CH3 only, and for this the pH will be equals to, as it is a strong base and a weak acid, so it will be half pK1 plus half pK2. So it will be a half pK1. Okay. So we calculate for these things. For them, for this will be the answer. I am solving for this one. So now number of moles of NaOH will be there. How many? So 0.01 moles are there. It is for Na positive is equals to OH negative. Now we know that number of moles of OH negative are this one. So it is in the molar. So in the 1 liter, how many moles are there? 0.01 is there. So concentration is what? 0.01 only. So now what we can do? So the POH is equals to minus log of concentration of OH negative. So after this is what? 10 to the power minus 2, and the minus is there. So POH will be 2. So we have to calculate for pH. So pH will be 14 minus 2, and it will be 12. So pH in this question will be turning out to be 12. So in these kind of questions, guys, always find out for the each option you are provided with, because directly on putting this you cannot say that the pH will be high or low here or here or here. You have to solve for each one of the option given to you. It will take time, but at least it will be surety that whatever the options you are putting is the correct here. So now the next question is given as the thermal dissociation of CaCO3. Thermal dissociation of CaCO3. So the thermal dissociation of CaCO3 is studied under the different conditions CaCO3 and CaO to CO2. For this equilibrium, the incorrect statement is. So the incorrect statement we have to tell, not the correct one statement. So what we will do is del H is dependent on T. There is a correct statement for every thing. Now equilibrium constant K is independent of the initial amount of CaCO3. Okay, it is also correct because why? Because CaCO3 is given in the solid form. So in the equilibrium constant will never be dependent upon the concentration of pure solids or pure liquids, because we consider them as the unity. So now the D option, it is del H is independent of the catalyst if any. This is also true because del H is what? Total energy change in the reaction. So the total energy change in the reaction is going to be same only. The catalyst only does is what? It just either it fastens the reaction, or if it is working as a poison, so it will lessen the rate of the reaction. So now the C option is left. Equilibrium constant is independent on the pressure of CO2 gas at a given temperature. It is wrong because, as you know, the equilibrium constant for this equation will be, so I write the K equilibrium in this will be what? K equilibrium will be what? Constant partial pressure of the CO. CO is also solid, so it will be CO2 only. So it will be partial pressure of CO2. So how can we say that it will not be dependent upon K equilibrium will be dependent upon the pressure of CO2 at a given temperature? So it is your wrong statement given to you. Now we will come to the numerical answer type question. So now in the first question, what is given to you? How many enantiomeric pairs can be obtained by the monobromination of isopentane? So if you are putting, let's say for the isopentane, first we will draw the isopentane. So it will be isopentane. Now it is given to you that we have to do the monobromination only. So the monobromination, then we will do Br2 and H2. So first we will see that how many different positions are provided in the question on which the bromine can come. So how many different positions are there? There are, I guess, 4 positions. So it will be 1, 2, 3 and 4. So we will take the possibility of all. So first I am writing bromine here. Then I am putting the bromine here. Then I am putting the bromine here, and lastly I am putting the bromine here. So now we have to check for the enantiomeric pairs as well. So now there is this center is what? Stereo center. It is again a stereo center, or it is again a stereo center, and here this is the stereo center. So now what will happen? Now this is not a stereo center actually, so this will not be the stereo center because there are the 2 methyl groups directly, and there are these 2 hydrogens. There is again 2 hydrogens, so there will be no stereo center in this case. So how many enantiomeric pair total isomeric product will be how much? So it will be is 1 stereo center. So it will be 2 from here, and it will be 2 from here. And how many it will be? It will be again here. So how many enantiomeric pairs will be there? So only the what we can say only again wait guys. So what will happen? This is again not an enantiomeric pair, so it will be only 1 only. Because there is the 2 methyl group same, it was mistake. So what will happen is this is like this one. So they are the methyl groups only. So there is no enantiomeric, so it is 1 here, and there is also no enantiomeric, so it is 1 here. So how many pairs? Only single this one, single this one. So how many pairs will be there? There will be 2 pairs of the enantiomeric compounds here. So the numerical value answer for this question will be the 2. So please check out the this what we say stereo centers very precisely. We always write in the open form of the compound. So now we will do the 72nd question, which is given a certain weak acid has a dissociation constant of this. The equilibrium constant for this reaction with the strong base is given as this. So we have to find out the value of X. So now certain weak acid has a dissociation constant. So the dissociation constant we have to check out. So first we will write both. We will write some weak acid. It will be H positive plus A negative. So can we say that on the dissociation of this we can get is what? It will be a K. So K for it will be H plus and A negative, and it will be a H. And it will be given as the 10 to the power minus 5 here. So now what will happen? It will be 10 to the power minus 5. Now for the next question, the equilibrium constant for its reaction with a strong base. So Ha plus, let's say positively NaOH. So what we will get? It will be get as H2O plus Na A negative. So this will be the thing that we will get. So what we can write now? For us the K equilibrium will be what? It will be concentration of H2O. I can also write this K negative directly. It would be this thing. So this is a K equilibrium. Now, if we see at these two reactions, HA is there, HA is there, A negative is there, A negative is there. Now what is not there? There is H2 and there is NaOH is not there. So what we can say? We can NaOH की जगह हम क्या बोल सकते हैं? That it will be directly OH negative only ना, because it is a strong electrolyte. So what will happen? We can write directly as OH negative like we did for the A negative. So it will be giving us something. So like A negative is there and H negative is there. So what we can do? Now we have Kw as what? H plus OH negative. H2 will be there. So how can we write this thing now? How can we write it? If we write Kw is equals to 10 to the power minus 14, and how we can write this? K equilibrium will be equals to, so to get the K equilibrium, what we can do? K equilibrium, so we can do this Ka upon Kw. How we will get is K I am writing H plus A negative H. Again I am writing this one as H plus OH negative, and it will be a H. Okay, so this H positive is cancelled by this H positive, this OH negative will go here, H2 will go here. So what we will get? K equilibrium. So K equilibrium is equals to what? Ka upon K W. Now we know that the Ka value is 10 to the power minus 15 and Kw value is always equals to 10 to the power minus 14. So Ka by Kw is K equilibrium. So what we will get? 10 to the power minus 5 upon 10 to the power minus 14. So it will be 10 to the power plus 9, which is equal to K equilibrium. So the value of X is given as 10x, so it will be plus 9K. So in this question, nothing was being given as such. It was just that weak acid was given to you and you are utilizing it with the, what we say, strong base. So what will happen? Neutralization reaction will be happening. Now to get that neutralization reaction, what we have to do is, to get this neutralization reaction, we will be doing what? We will be using the Kw value, because the Kw value is being utilized for the getting the desired equation that we want. Now, for the next question, what we will do? Now, this is a very important question, I can say, because half of the things in which the concepts will be cleared here. So a solution of HCOH is titrated with KOH solution when half of the acid is neutralized. AgCN is added to make a saturated solution. Calculate the solubility of AgCN here, and then we have to find out what? In a milligram per 100 liters of solution, in which K and Ks and K are given to you. So from where we will start? So we must know that the half acid, this half of the acid must be neutralized. So if the half of the acid is neutralized, it means half of the acid will be left. So what will be happening? So after that time, the solution will become what? A buffer solution in which there is HCOH, which is a weak acid, and there is also HCO negative, which is their conjugated phase. So what will be happening after the neutralization of HCOH is there, and there will be some HCOO negative. So it will be behaving as well. What we say? It will be behaving as well buffer. It will be behaving as your buffer solution. So what will happen now? So you will be using the equation which is pH is equal to pKa plus log. What will be there? pKa plus log A neg upon the HA. So what will be there? A negative. So now after this, what we will do? Now we know that the concentration of A negative and the concentration of the O negative is the given as what? Is the same, because why? Because it is a buffer solution. And in this thing, what we will do? Because A negative is equals to or HA. So what will happen now? Now the A negative concentration of A negative is equals to HA. So what will happen? We will be doing what? The Ka will be is equals, so the pH will be is equals to pK only, because the log terms will be getting cancelled out. So now what will happen? The Ka is given as 10 to the power minus 4. So the pKa will be is equals to 4, and it will also be equal to pH. So the concentration of H positive from this pH, because minus log of concentration of H positive is equals to pH, and it is the 4. So what we will get? We will get the concentration of H positive as what? Concentration of H positive as 10 to the power minus 4 here. Now the concentration of the 10 to the power minus 4 for the H positive is there. So what we can do? We can do one thing. We will use the Kw. So Kw is equals to what? 10 to the power minus 14 at 25 degrees Celsius. So which will be equal to concentration of H positive, which is 10 to the power minus 4, and concentration of OH negative. So for the concentration of OH negative, we will get what? We will get as 10 to the power minus 10. So please go through till now, till where we have done. Please go through this question. If there is anything you are not getting, please again check that what is the solution that we are doing, so that you don't get puzzled up, because this is a very bigger question to solve. There was a calculation into it. So now after this, what we will do? After this, we will do one thing. After this, we will say that you are provided with the till now. Now the AgCN has been added. So if the AgCN has been added, so what will happen? The Cn negative will neutralize the H positive which is getting generated. So after the addition of AgCN, what will be happening? The H positive will be getting. So this will be the reaction which will be happening after the addition of the AgCN. So we can take out as the Ka for the HCN is given to you. So Ka for the HCN will be equal to what? H plus. So don't get confused here. I am writing the Ka for this reaction. So Ka क्या होता है? It will be HCN going to this direction. So it will be your Ka. So now K is given as the H plus into concentration of Cn negative upon the HCN. So what is now? 10 to the power minus 10 is given to you. Now this is the another relation that we get. Now from here what we can find? Now from here we can find the total concentration of Cn negative, because the total concentration of Cn negative will be equal to concentration from Cn negative itself and the concentration from the HCN. So approximately we can say the concentration will only be equal coming from the HCN. Why so? Because the Cn negative which is getting formed, it is again getting attached with the H positive. So we can say whatever is the concentration of HCN present in the solution, it is due to the concentration due to HCN only. So now the concentration for Cn negative will get how? So the concentration of Cn negative will get the Ka multiplied by the concentration of HCN upon the concentration of H positive here. So now how do we get the concentration of Cn negative? So it will be a 10 to the power minus 6, because H positive is what? 10 to the power minus 4. So you will get as 10 to the power minus 6s for the concentration of Cn. So this is the second step in this question. Now in the third step, what we will do? In the third step, we will find out for the KSP for this thing. So for the KSP, we can say Ag and Cn. So for the KSP, it will be what? S into concentration of the Cn negative. So we will do what? In the next, we will say using the KSP will be equals to S square. So it will be S into 10 to the power minus 6s. it will be 10 to the power minus 6s square. Now Ksp of the reaction is given to you and it is given as 10 to the power minus 16. So the Ksp is equals to 10 to the power minus 6s square is equals to 10 to the power minus 16. Solving for the s, it will be 10 to the power minus 5 here. Now check out for the one thing that it is given in the moles per liter, but we have to find out what? We have to find out in the, it is given in the moles per liter. So we can say 1 liter is having these many number of moles for what? AgCN. Now for the mass of the AgCN, as we know, 133.89 gram per mole is the mass of the AgCN. So the molar mass of the AgCN is what? Molar mass of the AgCN will be equals to 133.89 gram per mole. So it will be molar mass of AgCN and it is the concentration of AgCN. So now how can we find out the gram weight of the AgCN? So we can find out this way, that mass of the AgCN will be equals to, this is concentration, these many moles per liter, and this is your 133.89 gram per mole. So till here is. So now mole to mole will be cancelled, it will be gram per liter. So after solving this, you get as 133.89 into 10 to the power minus 5 grams per liter. Now in 1 liter, these many grams are present. So what we have to find? We have to find out in the 100 liters. So in the 100 liters, what will be the answer? In the 1 liter it is. So in the 100 liter, how much has to be? It has to be 0.013389. Because in the 100 liters, what will be happening? 100 liters means 133.89 into 10 to the power minus 3 grams in per 100 liters. So if we can take in the milligram, what we will take? We will take as 133.89 milligrams is present. So this was a big lengthy question, but again very interesting question. You have to go step by step to get the answer. So now on the conversion of the what we say on the conversion of the Grignard reagent and followed by treatment with water, how many alkyl bromides is the isopentane? So we have to give the answer in this form now. So alkyl halide we can take any. So now how many the alkyl bromides can be there to giving the isopentane to you, we have to check. So now how many, for example, so we have to give what? We have to check for the alkyl bromides giving you what? Alkyl bromides giving you the isopentane from the reaction with I can write R and G and I can write with the body. So now we have to find out the number of alkyl bromides that can be there. So how many alkyl bromides can be there? As we did in the last question, 1, 2, 3, 4, 5. So it is 1 bromine, alkyl bromide is the third alkyl bromide, and it is the fourth alkyl bromide. So what we have to do? We have to give the possible answers. So in the possible answer, we have to check for the isomers also. So this is the one center. This is not the center. This will be the another. So these two are the what we can say stereo centers. So from there it will be 2 from here, 1 from here, and it will be 2 to the power 1. So it will be again 2, as it was also 2 to the power 1. So it will be 1. So how much? 1, 2, 3, 4, 5, 6. 6 alkyl bromides. These alkyl bromides can yield what? They can yield isopentane on reaction with what? On reaction with the Grignard reagent followed by the water. So now we are heading towards the last question. Last question is left. So in this question, as you can see, what is given to you? This is given to you log K and it is given to as 1 by T. So slope is given to you for this reaction. Now the temperature at which the rate constant of the reaction is this. So the rate constant is given to you. So what is left in the last thing? It is left that you are provided with the Arrhenius equation again. So now I am writing the Arrhenius equation here. So it will be what? Log K is equals to log A minus what? EA by 303R. It will be a Arrhenius equation. After this, what we can do? It is a Arrhenius equation. Log K is log temperature. So what will happen? This log K is given as your y-axis, and this 1 by T is given as your x-axis. It is your intercept, so it has to be your slope. So slope is given as minus 10 to the power minus 5. So it will be minus 10 to the power 5. Slope is equals to minus EA upon 2.303 R. So now the temperature at which the rate constant of the reaction. So please understand the temperature at which the rate constant of the reaction is. So they are giving you a rate constant at a one temperature. They are asking you for the rate constant at the another temperature. So now what equation we will be using here is the equation that we will be using here ultimately is log K2 by K1 is equals to EA by 2.303 R, and it will be 1 upon T1 minus 1 upon T2. For this thing, what we have to find out? Everything is there, only EA value we need to find out, and EA value we can find out from here. So we will get the EA value, so we will get minus, because minus sign will be cancelled minus sign. So it will be ultimately plus only. So the EA value that you are getting is 191471. So it will be around something 19417.2 joules per mole. So it will be 191471. Okay, so it will be, sorry. Now we are provided with the EA. You will put the EA here. K2 is being given to you. So K2 is 10 to the power, I am writing this directly here. So K2 is your 10 to the power minus 4. Second inverse, K1 is what? K1 is what for? 10 to the power minus 5. Second inverse, T1 was given as 500 Kelvin and T2 was given to you as 400 Kelvin. Sorry, T2 we have to find out. So in this reaction everything is present to you. So the answer for this question will be then. So the answer solving on this reaction is 526.315. So we will get the 526 Kelvin nearby. Exact answer will be the 526.315 Kelvin. So this was the solution for your part test 7 for the chemistry. I hope you got the answers clearly now. And if there is some doubts again, please go through the video, you will get the answers. Thank you guys.